expandable structures can be scaled almost indefinitely.
Sustainability, offering an integrated waste management facilities,
Regulatory.
Astronaut founder and
Max Space is pioneering a revolutionary approach to space habitation with its development of highly expandable inflatable habitats aimed at transforming how humans live and work beyond Earth. These habitats are engineered to drastically increase usable volume in a wide variety of environments, including low Earth orbit, cislunar space, the lunar surface, and even Mars. Unlike traditional rigid modules, Max Space's proprietary expandable structures can be scaled almost indefinitely while preserving structural integrity and predictability, offering a unique edge in the rapidly evolving market for off-world living spaces. Their first habitat is already slated for launch with SpaceX in 2026, marking a significant milestone in commercial space architecture. These inflatable modules are being designed for a multitude of applications, such as long-term habitation, scientific research, zero-gravity manufacturing, agriculture, space tourism, sports, and even entertainment facilities. The company is planning to develop habitats ranging in size from compact 20 cubic meter units to enormous 1,000 and even 10,000 cubic meter megastructures, each tailored to specific mission needs. Co-founder Aaron Kimmer emphasizes the importance of drastically reducing the cost and increasing the scale of usable space infrastructure to make space truly accessible for humanity. Without such innovations, he argues, our future in space may remain limited to small, costly endeavors. Max Space aims to break that barrier, redefining what's possible in human expansion into the final frontier. Satellite-based 5G is marking a revolutionary turning point in the way the world connects, communicates, and shares information. With the launch of this innovative network spearheaded by Sateliot, we are entering an era where high-speed, low-latency internet access is no longer confined to urban hubs or densely populated regions. Instead, it is becoming globally accessible, even in the most remote and underserved corners of the planet. By deploying a constellation of cutting-edge nanosatellites in low Earth orbit, Sateliot is laying the groundwork for a truly borderless digital world. This new 5G network is built to deliver seamless connectivity at ultra-low latency and high capacity, supporting everything from real-time data transmission to massive Internet of Things, IoT, networks. That means smart agriculture in rural areas, connected logistics across oceans, and emergency communications in disaster zones will now be possible without dependence on ground-based infrastructure. Whether it's remote sensors in wildlife conservation efforts, autonomous machines in isolated industrial zones, or mobile clinics in off-grid villages, this satellite 5G backbone enables rapid and reliable communication where it was once unimaginable. Beyond practical applications, this technology represents a major leap toward digital inclusion, ensuring that no region or population is left behind in the digital age. Sateliot's approach also supports industries looking to scale globally without infrastructure limitations, empowering innovation across sectors like agriculture, transportation, energy, and healthcare. From enabling predictive maintenance in supply chains to providing connectivity for life-saving equipment in remote hospitals, the possibilities are expansive and transformative. This isn't just about faster speeds, it's about redefining the internet as a truly global utility. Sateliot's satellite-based 5G network is not only a technical achievement, it's a critical enabler for a more connected, equitable, and resilient world. As we celebrate this historic development, it becomes clear that the future of global communication is not just wireless, it's limitless, and it's already in orbit.
Space architecture is rapidly emerging as one of the most vital and imaginative disciplines shaping the future of humanity beyond Earth. This specialized field focuses on designing the habitats, workspaces, and support structures necessary for human life in space. Environments that are not only safe and technically sound, but also comfortable and psychologically supportive for long-term missions. From lunar bases and Martian colonies to space stations in low Earth orbit, Space architecture merges engineering, scientific research, and human-centered design to tackle the extreme challenges posed by extraterrestrial environments. Key considerations include microgravity, limited resources, radiation exposure, life support systems, and the mental health of astronauts spending extended periods in isolation. These structures must be incredibly energy efficient, modular, and durable, all while fostering a livable atmosphere where people can work, rest, and maintain emotional well-being. It's not just about survival, it's about creating sustainable, functioning communities in space. With space agencies like NASA and emerging private companies such as SpaceX and VAST actively working on missions to the Moon, Mars, and beyond, space architecture has evolved from the pages of science fiction into a critical part of mission planning and design. These organizations are investing heavily in developing the infrastructure required to support life off Earth, including habitats that can be deployed on planetary surfaces or constructed in orbit. As humanity looks to expand its presence in space, architects, engineers, and scientists are collaborating to develop technologies and concepts that will define our extraterrestrial future. Space architecture is not just a technical discipline, it's a visionary framework that reimagines how and where human life can exist. It stands at the intersection of creativity and survival, marking the blueprint for humanity's next frontier.
The Christoph Clean City concept is a visionary approach to urban sustainability, offering an integrated waste management solution tailored for cities striving to reduce their environmental impact and transition toward a circular economy. Developed over the past decade by Christoph Industries, this comprehensive plan is designed to help municipalities dramatically cut their CO2 emissions and eliminate the traditional burdens of waste disposal. Rather than treating waste as a problem, the Clean City concept turns it into a valuable resource, leveraging advanced technologies and innovative energy systems to create sustainable, closed-loop processes. At its core, the concept is a master plan that combines over a century of industrial expertise with the latest in environmental engineering and green innovation. It incorporates new product systems and alternative energy resources, such as waste-to-energy plants, advanced recycling facilities, and clean fuel production, to build a self-sustaining ecosystem where materials are continuously reused, repurposed, or transformed into energy. This holistic framework not only improves operational efficiency and environmental health, but also enhances the overall quality of life for urban populations. The plan is backed by a diverse international team of 50 specialists who focus on executing financially viable and ecologically sound waste-to-value projects. By aligning environmental goals with economic feasibility, the Clean City concept enables cities to achieve zero waste targets in a realistic, scalable, and sustainable way. With a strong emphasis on circularity, renewable technologies, and cutting-edge waste treatment methods, Christoph Industries' Clean City initiative stands as a transformative blueprint for the future of urban living, one where sustainability is built into the very fabric of modern infrastructure. Astrolab's Flex rover, short for Flexible Logistics and Exploration, represents a major step forward in lunar mobility and infrastructure. Developed by California-based startup Astrolab, this multi-purpose lunar rover is designed to support both robotic and human missions on the Moon. In a landmark move, Astrolab has partnered with SpaceX to transport the Flex rover to the lunar surface aboard a Starship lunar lander with a mission targeted for as early as mid-2026. What makes Flex unique is its modular design, built to carry a wide variety of payloads, up to 1,500 kilograms on the Moon, and capable of traversing rugged terrain over thousands of kilometers annually. This design flexibility allows it to support a broad range of missions, from cargo transport and infrastructure deployment to science and exploration. Its low center of gravity and adaptive suspension system provide the necessary stability to move over uneven lunar terrain, especially in the South Polar region, a prime target for upcoming lunar activity due to its water ice deposits and extended sunlight periods. This first mission will be a rideshare flight, meaning Flex will be one of several payloads on board a SpaceX Starship during its lunar delivery. The mission is expected to carry over 1,000 kilograms of customer payloads, highlighting Flex's role not just as a rover, but as a mobile delivery and deployment platform for lunar exploration partners. Astrolab's founder and CEO, Jarrett Matthews, emphasized that Flex's ability to travel long distances gives it a strategic advantage. Its operations are less dependent on the exact landing site, making it adaptable for a variety of missions and partners. Ultimately, the Flex rover is being positioned not just as a single-use tool, but as a core element of a lunar economy, able to support NASA's Artemis missions, commercial partners, and future sustained lunar habitation. With its launch set to coincide with the new era of commercial lunar development, the Flex rover could become a familiar and vital presence on the moon's surface in the years to come.
Earth-to-Earth travel. SpaceX's Starship Super Heavy system, primarily designed for deep space missions, presents an ambitious vision for ultra-fast point-to-point travel on Earth. Elon Musk has proposed using this fully reusable rocket system to transport passengers across the globe in under an hour, making long-haul air travel obsolete. Key benefits: unmatched speed. Travel from New York to Tokyo in 30 minutes instead of 14+ hours. High passenger capacity could carry hundreds of people per trip, reducing congestion in air travel. Potential cost reduction. If reusability is optimized, costs per passenger could rival first-class air travel. Minimal fuel burn in the atmosphere. Starship mainly burns fuel outside Earth's atmosphere, reducing aerial pollution compared to traditional jets. Challenges and roadblocks. Technical feasibility. Landing a massive rocket near cities with precision is a major challenge. Safety and comfort. Extreme acceleration, G-force effects, and re-entry heating need to be passenger-friendly. Infrastructure development. Spaceports must be offshore, requiring new launch landing facilities near major cities. Regulatory approval. Aviation and space authorities need to develop new safety regulations for passenger spaceflight. Economic viability. Initial costs are immense, and ticket pricing must be affordable for commercial success. Current status. The first orbital test flight of Starship was completed in February 2023. SpaceX continues testing Starship's reusability and rapid launch capabilities. Earth-to-Earth travel remains a concept, but continued Starship development could bring it closer to reality. If SpaceX overcomes these hurdles, Starship could redefine global travel, making any destination on Earth reachable in under an hour.
Starship, SpaceX's most ambitious project yet, continues to push the boundaries of space exploration and engineering. The third integrated flight test, referred to as IF-3, took place on March 14, 2024, and represented a major step forward in the vehicle's development. Launched from the company's Starbase facility in South Texas, this particular mission lasted nearly 50 minutes and marked the first time the second stage completed its full-duration burn, successfully reaching orbital velocity. This milestone demonstrated that the spacecraft is now capable of achieving one of the key requirements for interplanetary missions. Though the mission did not end with a full success, the Starship vehicle ultimately broke apart during atmospheric re-entry. It still provided invaluable data for future improvements. Engineers are now better able to study the stresses and behavior of the vehicle under intense re-entry conditions. This iterative testing process is central to SpaceX's development philosophy: learn, rebuild, and improve rapidly. Starship is designed to be a fully reusable transportation system, built to carry both crew and cargo beyond Earth orbit, with eventual missions planned for the Moon, Mars, and beyond. Standing nearly 120 meters tall when paired with its Super Heavy booster, it's the most powerful launch vehicle ever developed. Capable of carrying over 100 metric tons to low Earth orbit, Starship aims to radically reduce the cost per launch, making space more accessible, not just for governments, but for private enterprise, science, and exploration. One of the unique features of Starship is its stainless steel construction, which offers both heat resistance and durability, while its flaps and aerodynamic controls allow it to perform controlled descents and landings, something essential for reuse and off-world missions. SpaceX envisions a future where fleets of Starships carry infrastructure, cargo, and colonists to the moon and Mars, turning science fiction into reality. The IF-3 flight test may not have ended with a flawless landing, but it proved the platform's capabilities are maturing fast. As development continues, each launch gets Starship closer to becoming the world's first truly sustainable deep space vehicle. With future tests already planned and refinements underway, SpaceX remains at the forefront of humanity's next great leap into space. The 6G vision for 2030 presents a bold and transformative look at the future of global connectivity, one where the speed, precision, and reliability of communication reach heights never before imagined. Unlike anything we've experienced with previous wireless generations, 6G technology is expected to become the invisible backbone of a seamlessly interconnected world, enabling innovations that once belonged only to the realm of science fiction. Picture a society where smart cities adjust lighting, energy consumption, and traffic flows in real time through advanced data streams, optimizing urban life and reducing waste automatically. Healthcare could be redefined, with remote surgeries performed by robotic systems guided with near-zero latency from thousands of miles away, and telemedicine becoming so immersive and precise that patients feel they're physically in the same room as their doctors. Meanwhile, the lines between physical and digital realities will continue to blur as extended reality environments become more immersive, tactile, and personalized, enabling not just richer gaming and entertainment, but also new platforms for education, work, and human interaction. 6G networks will support vast fleets of autonomous drones and vehicles, interconnected manufacturing hubs run by AI, and deeply responsive smart home systems that intuitively adapt to each user's needs. The speed and capacity of 6G will empower real-time language translation, Ultra HD streaming, and AI services that respond instantly anywhere on Earth. It won't just enhance the internet as we know it. It will turn the entire world into an intelligent, responsive, and self-optimizing ecosystem. This vision marks a technological and societal leap, where connectivity becomes as seamless and essential as electricity, shaping our environments, relationships, and possibilities. The 6G era isn't just about faster data. It's about smarter, more empathetic technology that redefines how we live, communicate, heal, travel, and create. The journey to 2030 is already underway, and with 6G at its core, the future of innovation truly begins now.